Hello, and welcome back to Learning with Lee. In today's episode, we are going to take a look at what are known as abstract classes. Abstract classes are similar to what we've already got going on here with item and weapon and then melee weapon and the like. So the difference between an abstract class and what's known as a concrete class is that you're able to instantiate a concrete class. An abstract class, similar to how we have over in intro.cpp over here, in which I can assign something to an item. However, at present what I can do is I could also do new item. However, it doesn't necessarily make sense that I have something that's an item when I want things that are specifically weapons, things that are specifically armors, things that might be specifically certain types of crafting things, or blocks in case we're dealing with Minecraft. So it's a matter of having it be able to create a brand new item with no additional information for it ends up probably actually being problematic for us because we don't necessarily want to be able to create a specific instance of an item. We only want to use its children classes and to have this define some common functionality to them. And in different languages, there are different ways in which this is done. In C# or in Java, we would just go up here and we would use the keyword abstract up here. However, in C++, there isn't the abstract keyword like there is in those. And the way in which you do that is via what is known as a purely virtual function. And what differentiates a purely virtual function or a virtual method, well, from a default virtual function or virtual method that can be overridden in its children, is that a purely virtual function doesn't have any definition to it. So basically all of this over here would be gone rid of and we would replace it with equals 0. And what that says is that any child class that's a child of item or a descendant of any of those children is going to have to implement getName before it can be instantiated, because at present, right now it's going to give us a compiler error in case, say, in weapon or in armor, we aren't overriding that. Because right now it doesn't know what to do if something calls getName, such as over here, in case I made this a new armor and tried to use getName, it's going to take me here, and it doesn't know what to do with this. It's basically just going to say, you need to tell me what to do for this to actually be valid, because right now it's not returning a string, it's not doing anything. So this happens to be a problem. Well, at present. However, the important thing is that because of this, nothing of type item can actually be instantiated. Otherwise, it will give you that error. And that's a way in which you can limit things so as that nothing can end up creating something specifically of type item, and instead we have to go to, say in here, where now we have overridden getName and it returns weapon. Or in case we then head on down to armor, we could then have it override that. And here's an important thing to understand. You can have something like this, which is an abstract class at present, but let's say then instead it was a concrete class, like this, because it doesn't have any pure virtual methods. So now then in here, let's say that we have ourselves a virtual, and we can just call this for now, let's just say that it returns, I don't know, let's go with a int, and we'll just call it attack. So is that you can actually make some attack with a weapon. And it might take in something like, or we could take in, say, a float x, float y, float z, in order to take in our coordinate positions. We probably would have a specific object for coordinates, and we'll get into that in a little bit. Well, relatively a little bit. But let's say that we don't want anything that is just a weapon. We want it to either be something that is a melee weapon, a form of a ranged weapon, or it could even be some form of like magic weapon. And these could give us different effects. So in D&D you might have like a wand that shoots out fire, and that would end up being a magic weapon. You could have a bow that shoots arrows, which would be piercing. But what it is that each one of those is going to have a distinct form of attack different from each other. Such as in some of them you might get things such as, for, like I was talking about with the wand, it might come out in a cone. So what you would end up having to do is you'd have to come up with some different way of representing that with this here. And there would be different ways in which we would do this, and in general this would actually not be this, but instead it would be a different class that would be used to represent that tag. I'm just using an integer for now for simplicity. However, what it is that even though item can be instantiated, and weapon derives from item, weapon itself cannot be instantiated because it has this pure virtual method. And it's important to note that this only goes basically downhill, as I referred to earlier. Or in case you view it as a family tree, it only affects your descendants. When you have something like this, it doesn't affect your ancestors. So this having a purely virtual function or purely virtual method in here isn't going to impact item. It's only going to impact its children, so weapon melee, weapon ranged, and any others that we would decide to add in. As a result, this would basically prevent this from being instantiated, but you could still actually have something that's a direct, just basic item. If for whatever reason you wanted to store something like a twig in your inventory and you didn't want to store it as any other type of item, and you just go, okay, I have an item that's a twig and it has some weight, some stackability, etc. And realistically, in general, for something such as Minecraft or Skyrim, you'd probably want to have that as something such as a crafting component for its main one, to signify that it can actually be used in crafting. Alternatively, we might just have something in here that says either whether it's used in a recipe, or we might then have our own separate thing for generating recipes as well as how things are crafted. But that would be something to discuss in a future date, because that would be a somewhat potentially advanced algorithm, as well as it would be an interesting thought experiment to think about the different ways in which that could be done. And it would require more time than really this involves. So that is the important thing about it. And in general, what I would be looking to do with this is that I would be looking to make this a virtual or a purely virtual class. And the way in which it would be purely virtual is if everything in here was virtual within it. And what that is known as in something such as Java or C# is an interface. And I know that we've already to a certain extent covered interfaces in case we head on back over to linked list and iLinked list, in which we use it to sort of act as a contract between the two in a way of limiting the exposure of our main method and our other classes to the specific linked list implementation. And while that's very valuable and very useful, in general, the way in which interfaces actually get done, at least in other languages, is that you don't have this implementation here. You just say that something happens to be derived from some interface, and then you pass it around as that interface. So as that basically I would have some form of constructor here. I wouldn't even honestly, I wouldn't need this destructor. I just would leave it as its own destructor previously. And this constructor won't need to be here. However, the important thing is that I basically have this operator here, which in turn doesn't do this. It just takes in an iList and an OStream, and then any children of this interface. And I would make this virtual, so it would basically be like, okay, this equals 0. And then when I would go over to something like linklist.hpp, I would instead have this derived off of iList, and then in intro.cpp, rather than using that, I would instead use iLists. Or where I actually currently have it stored is I have it over in here for these past items, but for now, I just would, rather than doing this iList here, I would store it as an iList and I would make it equal to a new linked list. But that happens to be something worth just noting for now, and we'll deal with it a lot more in the future once we start getting into more of architecture and design of how you actually use object-oriented programming in a professional manner. So that's probably enough for now. The important things to note is that in case you create any methods of the type in which you do this, and you have them be virtual, and basically if you have this equals 0, you have to use the virtual keyword before it, otherwise it will complain. So if you put any virtual followed by that in a class, you cannot specifically instantiate that class. It has to be defined within some of its children, and you can instantiate those. And what that allows us to do then is it allows us to store something and use something of type iList without having to care what type of its children it was, without having the ability to create something of type iList when it doesn't make sense, or type item when it doesn't make sense. So, thank you very much for watching. Have a wonderful day,